don't we have a treat here? A derivative question. Well, also an antiderivative question. Right, so quite a lot to this question. I've said question way too many times. Okay, let's get started. So we're given the derivative f prime of x as negative 3x squared plus 12x. Cool. We're told that the original function, so f of x, has a local minimum at 0, 5. We need to find the value of the local maximum. Alright, so first up, the derivative f prime of x is a quadratic, right, x squared, and it's negative. So it will look something like that, right? A bit sad. But we know when we anti-differentiate it, we will get a negative cubic, something like that. And we're told the minimum point, and we are looking for the maximum point. Alright, so what are we going to need to find that? Well, we're going to need the original function, right, in order to get its y value, but we're also going to need the derivative, right, which is given, to work out the x value, because we know maximum and minimum have a gradient of 0. So we will need the gradient function. Alright, so a few ways to approach this. I'll start by finding the original function. Right, so we're given f prime of x, and we will try find f of x. So to get that, we will anti-differentiate. So, to anti-differentiate, it's the reverse of differentiating, in that we first add 1 to the power. So, instead of squared, it'll be to the power of 3, but then we divide by that new power, like so. Similarly for 12x, we just write 12x, but now we add 1 to the power. So originally it's to the power of 1, so now it'll be squared, and we divide by the new power. So question for you, have we finished anti-differentiating? I'm hoping you're yelling no, because we have of course forgot plus c, the integration constant. Right, and why we have this is if we differentiate, we know that the derivative of a constant is 0. So to go the other way, we don't know what the constant will be. Right? C could be 0 because the derivative of 0 is 0, or C could be 3 trillion because the derivative of 3 trillion is also 0. So that's why we have plus C. So just simplifying our fractions a bit, we get negative x cubed plus 6x squared plus C. Cool. So we're halfway there. We have anti-differentiated, but we have this unknown constant C. So to solve for C, we need to substitute in an x and a y value. Right, so in for x will go 0, in for y, or f of x, will go 5. So doing that now, f of x becomes 5, x becomes 0, and you'll see that since all the x terms become 0, c will equal 5. Therefore, our original function, f of x, is exactly what we had up here, except we can now fill in c. So minus x cubed plus 6x squared plus 5. Great, so we found the original function. Now, was that the question? No. Right, the question was to find the value of the local maximum. Alright, so where to from here? So firstly, a few options. You could graph it to read off the max and the min. However, the question asks us to use calculus, not calculator. So if you got to this point, you would get an achieved. However, let's find the maximum using calculus. So for max or min, the gradient must equal 0. Right? The turning points, if you drew a tangent to them, they would be a flat line because the gradient is 0. So let's set our gradient function to 0. So minus 3x squared plus 12x equals 0. This is a quadratic equation, so we can solve for x if there are solutions, which we know there are because the question gave us that there's a minimum. So solving this, I would factorize it. So pull out 3x, left with minus x plus 4. Double check, 3x times minus x gives minus x squared, 3x times plus 4 gives 12x. So either 3x equals 0 or minus x plus 4 equals 0, because in order to multiply to give 0, one of the terms needs to be 0. So if 3x is 0, x must be 0, or minus x plus 4 equals 0, so x will be positive 4. So back to the question, we know that there's the minimum at 0, 5, minimum, and that would be at x equals 0. Therefore, the maximum will be at x equals 4. So we worked out the x value of the maximum. The question asked us to find the value. So what that's actually asking is, what is the coordinate? Right. So far we have the x value. We do now need the y value. So how do we get the y value? Well, good thing we did all that work to find f of x. So finding y value of max point. So substituting in x equals 4 into our original function. So negative 4 cubed plus 6 times 4 squared plus 5. Or 4 cubed, what's that? 16 times 4, 64, so minus 64. Plus 4 squared is 16, 16 times 6, 96. Plus 5. Quick maths, what is that? 30, 37. 32 plus 5, yep, 37. Alright, are we done now? Maybe. So, actually looking at the mark scheme, they say local max is 37. However, the question worded quite poorly in that they should say, what is the y value, if that's what they were after. So I'm going to write a conclusion that's more fitting of this, the wording of this question. So therefore, local max at x equals 4, y equals 37. Yep, just to be very clear. And if we got that far, you found the local maximum, that would be merit. So pat on the back. Well done. Have a good day.